Okay, so right here's one for number 8. I did one. This probably may not be the exact same numbers as what you had. I had to work one out. I wanted to make sure I got the correct answers before I shared it with you, because there's a lot of chance I could make a small error with as many steps as we have to do here. So if I was working this problem, two forces of 5 pounds and 8 pounds act at an angle of 32 degrees from each other. So what I like to do is I like to draw a picture of the setup. So I'm always going to pick one force, and I'm going to draw it in the direction of the positive x-axis. So it's always going to go directly to the right. And I'm just going to make this one my 8-pound force. Again, if you made it the 5-pound force, it doesn't matter. You would just find your answers in a different order. And then there's also a 5-pound force that is acting at an angle of 32 degrees from this force. So I'm going to draw another vector at the end of the 8-pound vector, and it's going to have a magnitude of 5 pounds. And then it tells me that these are acting at an angle of 32 degrees from each other. So basically what that means is this angle here is 32 degrees away from this angle. And because I drew this one directly to the right, then that means that this angle is up at a 32 degree angle there in yellow. I'm going to rewrite that. That doesn't look like a 32. Okay. So now, if I know this angle is a 32 degree angle, and I'm looking for the resultant vector, the resultant vector is the vector that starts here where the 8-pound vector started, and it ends here where the 5-pound vector started. So I'm making myself a triangle, and this is I'm looking for the magnitude of that vector, so I'm going to call that x. Well, I can also find this angle, the angle opposite vector, the vector with magnitude of x. Because if this outside angle is 32 degrees, to go all the way from here back to this line has to be 180 degrees. So that means I can do 180 minus 132, and that's going to give me this vector as a 148 degree vector. So now I know two sides and I know the angle between them, and I'm looking for the third side of a triangle. We can use the law of cosines. So here the law of cosines would be my resultant vector squared is equal to, and then your other two vectors. So I'm going to go 5 squared plus 8 squared minus 2 times, and then those two vectors again, 5 times 8, and then times the cosine of the angle between them. So times, in this case that's going to be cosine of 148 degrees. So now what I would do is I would plug all of this into my calculator. Right, I just did it all at one time. And when I did, I found that x squared is going to be equal to, and the value I got there was 156.843847 as far as my calculator would go. And so now that's what x squared is. So I need to solve for x, take a square root of both sides. And when I did that, I found x must be equal to 12.523, which rounds to be 12.52. So that's step one. The magnitude of the resultant vector is 12.52 pounds. Whoops. Okay. And so then from there, I'm going to change my resultant vector, so it's no longer an x, it's no longer the unknown. I now know this side is 12.52. Now the next thing it asks, it says, what is the angle between the 5 pounds force and the resultant force? So what it wants to know is, where does my 5 pound force and my resultant force, I'm looking for the angle between them. So that's going to be here, this angle I'm drawing in red. So now because I know an angle and the side opposite, I can use the law of sines to find that angle. So I said sine of 148 over 12.52 was equal to sine of, that's the angle I'm looking for, so let's call that angle alpha, over, and the side opposite that would be side A. And so now I need to solve for alpha, so I cross multiplied. So I had 8 times sine of 148 over 12.52 equals sine of alpha. And I'm kind of running out of room here. Let's see. So from there, I plugged all of this in my calculator. 8 sine of 148 over 12.52. And I got, and again, just leave this number in your calculator. You don't have to write it all out. I got something like 0.3386. Again, just leave that whole number all the way out in your calculator. And that's equal to sine of alpha. So now to solve for alpha, I need to take an inverse sine of both sides. So on your calculator, I'm just going to do the inverse sine of, and then I'm going to put in the previous answer. And so the inverse sine of the previous answer means alpha must be equal to, I got 19.79. And it tells me round to the nearest whole degree. So this rounds up to 20 degrees. So now if you go back to your big triangle, that angle that's in red I know is 20. And then it asked me for the third angle. So you could do the law of sines again. I didn't, because I knew the 3 angles of my triangles have to add up to be 180. So I just did 180 minus 148 minus 20, which got me 12. Okay, and so the next one is kind of the same thing, except they've already got a drawing and you've got a scenario that they're setting up here. You can see that one prospector is pulling with 80 pounds, the other is pulling with 60 pounds, and there's a 25-degree difference between those two vectors. And so we want to know, what is their total force that they're pulling with? Well, when it's set up like this, if I were to connect the two ends, that's not the resultant force, because they're both pulling in the same direction. So what we need to do is we need to redraw this picture so it looks like our triangles were set up before. So again, I'm just going to draw my first vector. I'm going to draw it directly parallel to the x-axis, pulling in the direction of the positive x-axis. So that is a vector that has a force of 80 pounds. And now the second vector here has a force of 60 pounds. And I know that the angle between them is a 25-degree angle. And so now, once I've got it set up like this, it's the exact same as the previous question. I'm looking for what is their resultant vector. So from the beginning of the 80-pound vector to the end of the 60-pound vector. And I know that the angle here must be 155 degrees because this forms a straight line, so it has to add to be 180. And you're going to just use the law of cosines again. So it's going to be x squared equals 60 squared plus 80 squared minus 2 times 60 times 80 times cosine of 155. And so again, you're going to plug all that in your calculator. When I plug mine in, I got 18,700 point a decimal. And again, that number is what x squared is equal to. So then to solve for x, I had to take a square root of both sides. And the number I got was 136.7499. And it told me to round to one decimal place. So that is 136.7.